Hello, welcome to this clip taking you through how to use the results of a titration to calculate the concentration of an unknown solution. So here's a typical question where it says that the solution of sulfuric acid has an unknown concentration and it's titrated against 25 centimeters cubed of a 0.105 mole per decimeter cubed solution of sodium hydroxide. So the sodium hydroxide is your standard solution, and it gives you the titration readings to the nearest 0.05 centimeters cubed. So the first thing to do is to work out the mean titer. So first of all, we don't use the trial titer because it's too inaccurate. Even if it happens to match for concordancy, e.g. within 0.10 centimeter cubed of one another, one of the other titrations, it shouldn't be used because it's not accurate. So the titers that we use are from 1, 2 and 3. So you need to choose which two are within 0.10 centimeters cubed of one another. So you should not be averaging these by adding up and dividing by 3, but choosing the two that are closest according to the concordancy criteria in the little arrow. So titration 1 and 3 should be chosen because they happen to be within 0.05 centimeters cubed of one another. So you add them up and divide by 2, which gives you 19.075 centimeters cubed. So now we can start doing some calculating. So we go back to the equation, we write it out using the correct mole ratios, and you can put data moles, equation moles answer down the left-hand side. So the first thing to do is to fill in the data. This is all the data we now have. So there's the data the question provided under the sodium hydroxide, and the data for H2SO4 we were able to work out from the titration data on the previous slide. So now we can work out the moles of sodium hydroxide because we have enough information to do that. And that gives us 2.625 times 10 to the minus 3 moles. So we did N equals B times C, remembering that the volume needs to be divided by 1,000. So the 25 gets divided by 1,000 and then that's multiplied by 0.105. So from the equation, you can see that there's a mole ratio. It's a 2 to 1 mole ratio. So we can use this to work out the moles of sulfuric acid. So if you look at the ratio, the number of moles of sulfuric acid is half the number of moles of sodium hydroxide. So you take your 2.625 times 10 to the minus 3 and you have it. Now the answer will be the concentration of the sulfuric acid, like the question asks us to work out. So C equals N over V. So we take 1.3125 times 10 to the minus 3 and you divide it by 0.019075. Now that is the 19.075 over 1,000. In the same way we did it for sodium hydroxide at the top. So that gives us 6.88 times 10 to the minus 2 moles per decimeter cubed. So you do it to 3 significant figures because in the data, 3 significant figures is the least sensitive from the question. So that's how you decide the appropriate numbers of significant figures for an LCR style question. Okay, thanks for listening. Until next time, see you soon.